we wanted to build one kind of spell checker, and for that we need our data.
Okay, I will just save me on that. I will.
Yeah. So for that we need the data, and our data was provided by ACL. It's Association of Computational Linguists, and so they had a competition. From that we take our data to work on, and so for training data we took corpus, several pieces of corpus, UMBC web-based corpus, and worked with 2 million words. And for data sets and for testing texts, we took that from Conal corpus. So our goal was to create a spell checker focused on defining and correcting MAC errors. So what are the MAC errors? MAC errors are those which appear when we are on in spelling, punctuation, and capitalization. So during our project, we could handle with those errors connected with spelling. So the question you may ask, why can't we just take a dictionary and see what words are wrong and what words are correct, and correct if they're wrong. But the problem was that we dealt with words that really exist, and they can only be
considered as correct.
Considered as correct, yeah. Yes. Just used in text. So, could you please return the previous slide? Thank you. And examples of these MAC errors you can see in these sentences. This knowledge may be relevant to them to tell his or her relatives. Their altitudes will be easily changed. So, for example, the third one with the altitudes, you know that this word exists, and the system can find as a mistake. Next slide? What we wanted to achieve in our project is to try implementing several language models and choose the best one for this kind of mistakes. Also, we had a real desire to practice hidden Markov models and practice Python. Yeah, and have fun. Okay, so about method and solutions, Charlotte will explain a little bit.
So I was supposed to use that.
Yeah, you can use it.
Oh, I can not use it.
Okay.
Okay, so first we wanted to have a better knowledge about our database and about what we were going to use. Not database, sorry, dataset. And so we implemented a unigram just to have an idea about the parameters that were relevant or not relevant and what kind of errors were in this dataset. So first, okay, we have this better understanding. Second, we realized that two things were kind of important, not only the words before the word you wanted to evaluate, but also the word after the one you are evaluating. So this was the first founding. The second is that, of course, part of speech we thought will be really helping in improving our algorithm. Our solution, in the end, was this custom n-gram models, who was based on a previous context and also a posterior context. Before going to that model, we tried several runs with more or less success. So the first one was with part-of-speech tagging. So actually, it performed less than the just n-gram, so without the part-of-speech. Second one we tried was the conditional random fields. So it was quite long and slow to train. So we considered as a failure and stick to something easier. And actually, so we tried the unigram, we started by that, and we actually it's performing quite well, and it's really simple. So simpler, better, faster.
What? There was really better method to work with.
Okay, so this is the results of the benchmark available from the Connell dataset. So here you can see all the teams already in the benchmark, and you can the figures of the recall. So for the MEC, you can see that first the best score is right here. So only 46% recall. And that we've got with our n-gram model 41%. So can you please go to the next slide? So this is actually like a pretty good result compared to the state of the art for this benchmark.
It's awesome.
Yeah.
Yes.